Section 2.6 involves algebraic proofs. This is where they began to teach you about how to use proofs, but they're going to teach it to you with something that you know. Before we start, we need to go through some properties that you are familiar with, you know, but these are properties that we are going to use in our algebraic proofs. A reflexive property basically says A equals A. You reflect back the same thing you have. Symmetric property, if A equals B, then B equals A. Transitive property, if A equals B and B equals C, then A equals C. Addition and subtraction properties, those are if you're doing algebra and you have like x minus 4 equals 10. That's showing you that in order to solve for the x, you would add 4 to both sides. So what you have just done is you have done the addition property. Okay, because that's going to give you x is equal to 14. If you subtract to solve for something, that is the subtraction property. Multiplication and division, you can probably figure out if I have 2x is equal to 12, then in order to solve that problem, I would divide by the 2. I have used division property. It's what I do in order to solve for an x. Substitution property, basically, rather than saying 2 plus 3, you could say, rather than saying that, I can say 5. I've substituted the answer for what the two parts of it were. Distributive property, you know, on distributive property, you have x plus 4. So I have to distribute the 2 with the x and the 2 with the 4. So these are all properties that you have done before. You also, and I'm going to throw this in here, you have reflexive property with a line segment. So, like for instance, you might have AB is equal to AB. With symmetric property, it is also applicable to a line segment. So you can say if AB is equal to CD, then CD is equal to AB. You can just switch sides. You also have transitive property when it comes to line segments. So if AB equals CD and CD equals EF, then AB would equal EF. Remember on these you have to have a tie. On this one the tie is CD. Up here on this one the tie is the B. Okay, so these are all properties that you're familiar with already, and we will be using them to write an algebraic proof. Now, the thing about a proof, there are certain things that every proof has to have. These are what we call a two-column proof or a formal proof, and this is what we're going to be doing through the whole time that we're doing proofs. Every proof needs to have your given, so you must write your given down. Even if it's up here, you must rewrite it as part of your proof. Okay, you're going to find that you're going to want to do all the parts that I tell you to do to begin with. Just in case you don't get the proof right, you're still going to get some points for putting the things in place, like the given. Here, the given is what comes after the if. It's your hypothesis. So here's my given. 3 times x minus 2 equals 42. And this is what I'm trying to prove, is x equals 16. Then I'm going to do 2 columns. Over here is going to be my statements. And on this side is going to be my reasons. You can't just say something without there being a reason for saying it. Okay, you have to have concrete evidence that what you say is true. All right, so the very first thing that you're going to put on here is you're going to put your given. So I have 3 times x minus 2 equals 42. The reason I can write that is it is given. Okay, now on every proof you do, you should be able to get at least that far. So you should be able to write the given, the proof, and often this says prove. That's probably a better way to write this, is prove. Okay, and then you're going to do your 2 columns. You're going to label this statements, you're going to label this reasons, and you're going to number. So what goes with statement number 1 should be reason number 1. So you always have to put your given down. When we go to do the geometric proofs, you're going to want to draw your illustration here. All right, now we're going to go step by step through this, and you're going to have to tell me perhaps what the reasons are. You should be able to do that. So you look and you go, first thing I'm going to do is 3 times x, and then 3 times 2 equals 42. Why can I do that? It's called distributive property. Then the next thing I'm going to do is I'm going to write this consolidated or simplified. And rather than writing 3 times 2, I'm going to write what 3 times 2 is equal to. That is substitution. So I substituted the answer for 3 times 2. Next thing I'm going to do is I'm going to add 6 to both sides to be able to get, I'm trying to get the x by itself. So I have 3x minus 6 plus 6 is equal to 42 plus 6. What I did was I added in order to solve, so that's the addition property. Now I'm going to consolidate it or simplify it. So I have 3x is equal to 48. That would be substitution. Then I'm going to need to divide to get rid of that 3. And that's because I divided. It's called division property. Okay, you don't have to put properties on each one of these because we know that that's what it is. And then my last step here is x is equal to 16, and that is substitution. You've just completed your first proof. Okay, now these are algebraic proofs, so it's taking something you know, and it is allowing you to do it with a proof. All right, now I've kind of hole punched this, so I can't really see it, so we're going to take a guess at what it said. Okay, so our given is 2 times 5 minus 3a minus 4 times a plus 7 equals 92. Prove that a equals negative 11. I hope I got that right, because if that's not what we were trying to prove, this might be a bit of a problem. We're going to try. Okay, so first thing I do is I make my 2 columns. This is statement. This is reason. Okay, so I have to rewrite my given. So 2 times 5 minus 3a minus 4 times a plus 7. That might be plus a. 1 second, let me look at this. I think that might be right. We'll try it. Okay, so that's going to be your given. Then the first thing you're going to do is you're going to do distributive property. So I'm going to go 2 times 5 minus 2 times 3a minus 4 times a minus 4 times 28, or 4 times 7. Okay, and that's going to be distributive. And then I'm going to do my substitution here. So I have 10 minus 6a minus 4a minus 28. And that's going to be substitution. Then I've got negative 18, which is going to be what I get when I get those two. Oops. Didn't put our 92s in there. Okay, and then I have a negative 10a is equal to 92. So that is going to be substitution again. I wrote what they were equal to. Okay, now I'm going to add the negative 18 to both sides. Or actually, I'll have to add a positive 18 to get rid of it. Okay, so that's the addition property. And then I would have negative 10a is equal to 110. And that would be substitution. Then I would have to divide to solve it. So negative 10a divided by negative 10 is equal to 110 divided by negative 10. So that would be division property. And then my last step would be substitution, which is exactly what I was trying to prove. And so your last thing should be what you were trying to prove up there. Okay, so hopefully it's giving you a little bit of an idea how to do one of these proofs. I am guessing that that says 7d plus 3, so that's what we're going to go with. Our given is 7d plus 3 over 4 equals 6, and what we're trying to prove is that d equals 6. All right, again, 2 columns, statements, reasons. So my statement, of course, I have to rewrite my given. And that the reason for that is it's given. Okay, then I would need to multiply both sides by 4. You guys know how to do this. You're just going to have to make sure you're showing each step. like way back when you first learned how to do it. Okay, so what we did was we did the multiplication property, because I multiplied both sides by 4. Then I know that on the left-hand side I have 7d plus 3, and on the right-hand side I have 24. So that is substitution. Now I need to add a -3 or subtract 3 from both sides. So that's going to be the subtraction property. Then what I have left on the left-hand side is 7d. What I have on the right-hand side is going to be 21. And I have a funny feeling there was something else that was right there. So I'm not sure. Not sure what that statement might have been. All right, well, we're going to change this since we didn't know what it was, and we'll make that a 3. Okay, so this is going to be number 5 is substitution. And then I'm going to have to divide by the 7 to solve it. And that's division property. And then, of course, your last step is going to be your substitution. All right. Hopefully you get the concept. I'm sorry about those hole punches that we can't see it. Okay, then you have the same principle can be used with geometric proofs. So basically you have it's a rectangle. So actually we're going to go ahead and draw the rectangle out here so that we can see it better. It will help us do the proofs. We've got A, B, C, and D. And we'll go ahead and do our given. Given is rectangle A, B, C, D has sides AD equal 3, AB equal 10, and what we're trying to prove is that AC equals BD, and we'll put lines on these because technically they're line segments. Okay, so 2 columns here again. Statements, reasons. Statement 1, rectangle A, B, C, D has sides AD equals 3 and AB equals 10. And the reason is given. All right, now we can go and we can go, well, if AB equals 10, then, well, and we want to know AC. Okay, we've got AC and we've got BD. So we have got, we can go ahead and pencil in some stuff up here to help us see it. So AD is 3 and AB is 10, which also means that BC equals 3 and DC equals 10. And the reason is that is the definition of rectangle, because sides opposite each other are congruent. Okay, so that's the definition of rectangle. So I can also do this. Okay, now what I'm trying to figure out is whether this, okay, the AC, which is your diagonal, and AC is a diagonal there. So if you look at that, you can do Pythagorean theorem on this and figure out the measurement. So that's going to be my third step here, is going to be 10 squared plus 3 squared is going to equal BD squared. Okay, and I don't really technically even have to do that out, but we can. So that's going to be 100, and that's going to be a 9. So we have BD squared is equal to 109. And at the same time, I'm going to do the 10 squared plus 3 squared is equal to AC squared. So AC squared is equal to 109. Okay, now you guys know that is Pythagorean theorem, which you've already talked about this year. All right, now if you look at that, I have BD equals the square root of 109. And I also have that AC equals the square root of 109. Okay? And the reason why I can do that, and there's not really, we didn't go over a theorem, but we could go ahead and put it in as substitution because we're solving it. Now, if they're both equal to 109, I can literally take that 109, and I can substitute. Now look, rather than writing the square root of 109, I write what the square root of 109 is equal to, which is AC. So BD equals AC. Okay. I substituted, rather than writing this, I wrote what that was equal to. So I used substitution again. Okay. So that is a geometric proof. You're just going to be starting on those. We'll be working more and more and more on them. And the more you do, the better you get. So on page, and this is mostly algebraic proofs, on page 97 through 98, I want you to do 14 through 30 even.